Welcome all. A small revision in chemistry part for 10th standard Cbse. Chemical reaction and equation as first. Chemical reaction. Anything which reacts and gives a product, we call it as a chemical equation. Example, grapes, food is cooked, and that is what the first page given in your textbook. And example, magnesium, when it is burnt in an oxygen, in presence of oxygen, it will gives out an ash. That we call it as a chemical reaction. How can we write this as an equation? We know very well magnesium and oxygen has reacted and gives a product as ash. The same thing, zinc granule which is reacted with dilute hydrochloric acid or dilute sulfuric acid. What will be its product? That is what. See, in the beaker, zinc granules is there, dilute sulfuric acid is added, and hydrogen gas will be liberated. This is what the reaction is. How can we write all these reactions? For that, magnesium plus oxygen gives magnesium oxide. This is a word equation. How a chemical equation comes? When two reactant like magnesium ribbon burnt in presence of oxygen gives MgO, that is magnesium oxide. It's a symbolic representation of that reaction, that we call it as a chemical equation. How it has to be balanced? All the reactions must obey law of conservation of mass. What is that? Mass neither created nor be destroyed in a chemical reaction. So the reactant and the mass of the product should be equal. The mass of the reactant and mass of the product should be equal. For that, how can we balance it? The second example, zinc and sulfuric acid gives zinc sulfate and hydrogen gas. That has been given as a equation, and for this the left hand side are called as Zn H2SO4 are called as a reactant, and ZnSO4 plus H2 it's called as product. We have to write all the elements or atoms in left hand side and the right hand side which is present. Zinc, hydrogen, sulfur and oxygen are present. So we have written everything, and number of atoms that present in left hand side and the right hand side has to be tabulated. Zinc 1 and right hand side 1, hydrogen 2 and right hand side 2, sulfur 1 and right hand side 1, oxygen 4 and 4. Everything has been balanced, so no need to balance it. It is balanced equation. It obeys law of conservation of mass, so it is a very right reaction. Now iron, when it is reacted with oxygen in presence of moisture, we call it as rusting of iron. That is what an example. See, iron plus water gives iron oxide plus hydrogen gas. How it should be? In that reaction, it has not been balanced, because in left hand side it is given as 1 iron, whereas in the right hand side it is 3 oxygen, here 1 and here 4, and this side hydrogen 2, and to the right hand side it is 2. So hydrogen is balanced, iron is not balanced, oxygen is not balanced. First of all, we have to find the bigger number. Which is the bigger number here? 4, which has 4 oxygen. So right hand side which has 4 oxygen, that should be balanced here. All the time you should write it as a coefficient, not as a superscript or subscript. It should be written as a coefficient. What is a coefficient? The number which has been written in a alphabet. Here, if you are writing as 4 in front of hydrogen, we cannot write 4 in front of oxygen. So that is what the steps has explained here. Okay, we have to divide into 2. Iron, hydrogen, oxygen, how many has given there, that we have to write it here, and then we have to find it out. See, in the last equation, the equation would be iron plus 4 water molecules plus iron oxide plus hydrogen. So there, if you are writing 4 in front of water molecule, the hydrogen will also become as 4. So already H2 was there. So if you write 4 in front of hydrogen, it will become 4 2s are 8 hydrogen. Here in left hand side, 4 twos are 8 hydrogen and 4 oxygen atoms. And iron has not been balanced here. So if you write 3 in front of iron, it will be balanced. You can see the last the final step of the reaction, that is 3 iron plus 4 molecules of water, which is gives iron oxide plus 4 atoms of hydrogen. So like that we can do a lot of reactions, and this is what a very important reaction. The last you have seen, no, that is what the photosynthesis. Photosynthesis is a reaction that alone, if you try it, you can do it anything. Okay, carbon dioxide plus water gives glucose. Okay, glucose, what is the formula for glucose? C6H12O6. So if you are writing that, it's the same thing what you have done for the rusting of iron, you have to do the same thing here. Okay. And types of chemical reaction: combination reaction, we know, combustion reaction, exothermic, endothermic, decomposition, in decomposition, thermal decomposition, electrolytic decomposition, and photolytic decomposition, and single displacement, double displacement, reduction reaction, oxidation reaction, and redox reaction. These are the reactions we are going to see. A combination reaction, example, calcium oxide plus water. When calcium oxide, that is quicklime, when it is reacted with water, you generally you have to know the common name of all the chemical substances. Calcium oxide is quicklime, and it will turn into, when water is added into it, it will turn into calcium hydroxide, that is slackline. Okay, that you have to be very careful on that. That is a very simple example for combination reaction. All the reactions when you are writing, you have to be very keen that it must obey the law of conservation of mass. That means you have to balance every reaction which you are writing. Okay, so burning of coal is a very good example for combustion reaction. Carbon plus oxygen gives carbon dioxide. The formation of water molecule, that is hydrogen and oxygen, gives water molecule. And methane, that is burnt in gas, that is also oxidation reaction or combustion reaction, where oxygen is added. Okay, so that is what a very good example. And decomposition reaction, example for decomposition, ferrous sulfate. Ferrous sulfate, when it is heated, okay, ferrous sulfate, when it is heated, it will turn into ferric oxide plus sulfur dioxide and sulfur trioxide gas will be evolved. This is a very easiest example. Okay, and calcium carbonate, that is also very easiest example. When calcium carbonate is heated, it will form calcium oxide plus carbon dioxide gas will be given out. Okay, a single product when heated, it gives out two products, is called as thermal decomposition. Very simple. Okay, all the time you have to be careful on what you are writing. All the reactions must be a balanced equation. If it is not balanced, you won't get marks. Okay, electrolytic decomposition, example, water. Water, when it has been electrolyted, it will gives out hydrogen and oxygen gas. Okay, so that is electrolytic. And photolytic decomposition reaction, that is silver bromide. When it is kept in sunlight, it will gives out silver and bromine. Okay, so this is what a very easiest example. And how the displacement reaction that takes place in copper sulfate. Copper sulfate solution has taken in a test tube. When iron has kept into it, it will displaces. Copper displaces on iron, and the solution which is present in blue will turn into green in color, that we call it as ferrous sulfate, and copper will be taken place. A very simple example that is very important too. Okay, it is asked in MCQs even. Okay, iron plus copper sulfate gives iron sulfate plus copper. A very simple reaction. And double displacement example we know very well, that is sodium sulfate plus barium chloride. A very easiest example. Okay, you have to be very careful. See, these reactions are there in grade 9 itself, you would have studied. Okay, when sodium sulfate Na2SO4, when it is reacted with barium chloride BaCl2, both are in aqueous state. Okay, it should be in an aqueous state. It will gives out barium sulfate and sodium chloride. Okay, it's a very easy thing that you can balance it. Always sodium chloride, most of you are writing Na2Cl, it's not correct. Okay, it will be NaCl. A coefficient is 2, it's not a subscript, so we have to be very careful on that. Okay, and what is oxidation reaction? The addition of oxygen is or removal of hydrogen is called oxidation reaction, or gaining of oxygen and losing of hydrogen is called as oxidation reaction. Whichever you are comfortable, you go with that. Say copper plus oxygen gives copper oxide, that is also magnesium, which we have seen in the first example, that is also one of the easiest thing. When oxidation and reduction takes place simultaneously in one reaction, that we call it as redox reaction. See, in copper oxide plus a hydrogen gas, when it is added, hydrogen gas is involved in it and oxygen has liberated as water molecule. So here both oxidation and a reduction simultaneously takes place, so it is called as reduction reaction. And corrosion we all know very well, as same as how moisture, that is water, reacted with iron gives out iron oxide plus hydrogen gas, that is a example for corrosion. And what is rancidity? Very important question. Oxidation of fatty acid is called as rancidity. The oily food which is kept out for a long time, the oil which will be reacted with atmospheric air, or it will be reacted with oxygen, and the oil will be oxidized so that it will get stinky. That's what it has been kept. See, especially in potato chips, why it is kept in a packed example, some of the companies which will be providing the chips packets which are filled with gas. Why it is filled? The nitrogen gas has been filled into it because nitrogen won't react with oil, so that it has been kept to preserve it for a long period of time. So these are the very important questions will be asked in the examination. Acid, bases and salts. First and foremost thing, define acid. Acids are derived from the Greek word called acidus, which means sour in taste. The physical properties of acids are, it will be corrosive in nature, which will be liberates H plus ion, that hydrogen ions in water, and it has been divided into two, that is organic acid and inorganic acids. Organic acids are weak acids, inorganic acids are strong acids. What are the organic acids? Like which has been taken from organic matters, example acetic acid, citric acid, those things which will be called as weak acid or organic acids. And inorganic acids or strong acids, example sulfuric acid, hydrochloric acid, those things are strong acids. Okay, how acids and bases reacts with metal, that is what we are going to see. Very simple example. In the previous chapter we have seen, no, zinc reacts with sulfuric acid or hydrochloric acid, which will be gives out zinc sulfate and hydrogen gas. Moreover, you have to keep it in your mind, that is whenever an acid reacts with a metal, it gives out salt and hydrogen gas. That we have to be very keen. Like HCl, HNO3, HCH3, COOH, that is acetic acid, nitric acid, hydrochloric acid, all these acids which will be reacted with a metal like magnesium, zinc, those are highly electropositive substances which will be reacting. Okay. Acid plus metal gives salt plus hydrogen gas, as I said, and sodium hydroxide is a base. When a base reacts with an metal, when what will happen? It will gives out a double salt. Example, sodium zincate is an example, plus hydrogen gas will be liberated. What is a base? Base which will be bitter in taste, which will be soapy to touch. It is also corrosive in nature, which will be producing OH minus ions in water. And sodium carbonate, how sodium carbonate, metal carbonate, when it is reacted with an acid, that is sodium carbonate Na2CO3, when it is added with the HCl or sulfuric acid H2SO4, it gives out NaCl when it is in hydrochloric acid, Na2SO4, that is in the sodium sulfate in sulfuric acid, plus water plus carbon dioxide. This is a basic thing. Whenever metal carbonate or metal bicarbonate reacts with an acid, it gives out a salt and water and carbon dioxide. Okay, so these are the very simplest thing that you can do. When base plus acid or acid plus base gives salt and water, it's called as a neutralization reaction. Metal oxide plus acid gives salt and water. That is also one of the important question will be asked. Examples are many. You just go through. It's all our textbooks. You can understand very easily. What happens to an acid or a base in a water solution? What will happen? It will be in a water solution. Dry. See, whenever HCl plus water gives, it will form H3O plus Cl minus. So it will, the ions will be liberated into it. Okay. Sodium hydroxide, when it is added with the water, it will produce sodium plus OH minus, that is in aqueous state. Okay, so all the hydroxide will be like that. Okay, acid plus base gives salt and water. What will happen? How can we find either acid or a base? That is what a pH, that is potence, the P which is called as potence, and H denotes H plus ions, and it is also called as, another one is there, POH, that is potence of hydroxide. How to find the power of hydrogen? That is called as potence. Potence means power. See, the scale has divided into different colors from red to blue or violet. Okay, the blue one is 14 and the red one is 0. When it is 0 to 6, it is called as acid, and 7 is a neutral, and 8 to 14 is a base, of course. 0 to 3, it is strong acids like HCl, HNO3, H2SO4. Where 4 to 6, it's called as a weak acid like citric acid, CH3COOH, those things comes under a weak acid. And what are bases? Weak bases are calcium hydroxide, magnesium hydroxide will be comes under 10 to 12, and which will come under 14, like sodium hydroxide, which will be in a more pH, it will be a inorganic substance. Okay, so that we can understand. Why the pH of blood, how will be the pH of the blood will be? pH of the blood must be neutral, that is 7, and water must be in 7. That's what it is called as neutral substance. So you have to keep it in your mind. Bee stings, what will be the remedy for the bee stings? That is also one of the important question. Applying calcium on the distinct area that will react together. That is what ant or bee, which will have a formic acid, it will be injected into it. If you apply calcium on it, both acid and base reacts together, forms a neutralization. It will neutralize and reduce the pain. Okay, have you ever been stung by a bee, honey bee stings? This is one of the important question. More about salts. Family of the salts are: sodium chloride is a rock salt in common, table salt in common, and Gandhiji, which is a very important thing. Okay, Dandi March is a very important thing about salt. The common salt is otherwise called as rock salt or sea salt or common salt, and that is what. Okay, that is a very important thing. Electric How sodium hydroxide has been produced. Sodium chloride, which is called as a brine solution, it's a very important word, tricky word. Brine solution, which is added with the water, it will gives out sodium hydroxide plus chloride gas plus hydrogen gas. When it has been electrolyted, these things will be given out. Okay, from the chloride gas, when calcium hydroxide, when it is added together, it will gives out calcium oxychloride plus water. What is calcium oxychloride? Bleaching powder. How it is used and where it is used? It is used as a bleaching agent and oxidizing agent. It is used as a disinfectant. Okay, and what is a baking soda? NaHCO3, that is sodium bicarbonate, where it is started from extracted from sodium chloride and with water, carbon dioxide and ammonia. Ammonia is a very important thing that is asked in the examination even. Okay, will give you have a lot of procedures, steps in between this. Those things you will study in your higher classes. I'm just rushing out because this is a revision class. NH4Cl plus NaHCO3, that's what. Okay, and what is water of crystallization? The amount or the ratio of water that present in it is called as the water of crystallization. That is Na2CO3, 10H2O gives Na2CO3 10H2O. That when it is added with plus, and here it is kept a dot, that we call it as a water of crystallization. Very important thing. And how the water of crystallization, you can see, okay, in the second para, how gypsum is formed. Calcium sulfate dihydrate has been formed. That is what gypsum. And what is plaster of Paris? Calcium sulfate hemihydrate, that is half H2O. That's a very important question asked in the examination. Calcium sulfate hemihydrate, that is plaster of Paris, when it is added with one end of molecule of water, it gives out calcium sulfate and water molecule. Okay, two water molecule. These are the important questions. Neutralization, these are the important questions you have to go through. Coming to the topic metals and non-metals. Metals are solid in state, shiny, lustrous. That is what lustrous. It will be ductile. It can be malleable, which can be made into thin sheets. These are the general things. It will be conduct heat and electricity. Okay, example iron, copper, aluminium, magnesium. Those are the things. Exceptional cases are there. I said all the metals are solid in state. Some are in liquid. Example mercury. Everyone knows that. But calcium is not a lustrous and hard, but it is also a metal. Okay, everyone knows that calcium, right? It's a metal. And some of the metals are soft even. That is what example highly electropositive elements or atoms. Example sodium, potassium, which are very hard to which very easy to cut, even cut through the knife or the exceptional cases. Okay, which will conduct heat and electricity. That is what the example is given. And non-metals are mostly solid. Example carbon and allotropes of carbon, we know very well. Its boiling point and melting points are more. Okay, and those are the important questions. Chemical properties. Metal plus oxygen always gives metal oxide. Okay. Copper reacts with oxygen, gives copper oxide. This is oxidation reactions too. So the same reaction is repeating again and again. So you have to be very careful on these things. Okay. Aluminium oxide reacts with acid and base here. Both it will be reacting simultaneously. These kind of substances we call it as which is called as amphoteric oxide, which will be react both in metal and non-metal. Okay, so these are the important thing. Metal plus water gives metal oxide plus hydrogen gas. Metal oxide plus water gives metal hydroxide. See, all metal which is will not react with a cold water, all metal will not react with a hot water, all metal will not react with steam. Some will react with cold water, not in hot water and steam. Some will react with hot water, not in cold and steam. Some will react with only steam, not with cold or hot water. See, potassium which is react with the cold water itself, it will gives out enormous amount of heat, like sodium too. Okay. Calcium reacts with the water, which will gives out calcium hydroxide. Aluminum reacts with the water, here the gaseous state, which is steam in state, which is reacts aluminium oxide. Iron reacts with water, that is in gaseous state, that is steam. Okay. That you have to keep it in your mind. Metal that is reacted with the dilute acid gives salt and hydrogen gas. These are the repeated questions that is asked. And the same thing, displacement reaction. And the reactivity series, we have to be very careful. Potassium is the strongest in the series, and gold and silver, those things are very least in the reactive strength. You have to look into the strength of the reactant so that you can easily identify which will be displacing each other. So that is what one of the important question asked. And dot structure, whenever they asked for the dot structure, you have to draw the uh, what the valence electrons. What is the valence electron? The number of electrons that is present around the outermost shell of the atom is called the valence shell. See, so for sodium the atomic number is 11, the outermost electron is 1, so 1 dot has kept. For chlorine 17, 7 is the outermost shell, so 7 electrons in the outermost shell, so they kept as 7. So for chlorine it will gain 1 and sodium gives 1. So that is what sodium is positively charged. So those things, electronic configuration is also very important thing. Occurrence of metal, gold, silver, those things are available in a free state, and other metals which will be available in its along with its ore. What is mean by ore? The impurity that is present along with the metal, we call it as ore. Okay. Some of the ores are oxygen, when it is added with metal, that we call it as oxides ore. Sulfur, which is called as sulfide ore, and carbonate ore are there. Okay, so the removal or the purification procedure of metal, we call it as metallurgy. Okay, according to the reactive strength, calcium, magnesium, aluminum, or highly reactive elements, so that can be separated or purified with a process called electrolysis. Zinc, iron, lead, copper are reduced by using reduction. Okay, which has been roasting can be done. And silver and gold, of course, it will be available in a free state. See, these the flow chart is very important. Okay, concentration of ore, metals of a high reactive, medium, and low reactive. For the high reactive, electrolysis, and low reactive, it is sulfide, and roasting will be done. Okay, what is mean by roasting? Okay, roasting means burning in the presence of oxygen is called as roasting. Calcination is absence of oxygen. Roasting, example zinc sulfur sulfide. When it is it's a sulfur ore. Okay, when oxygen is added, zinc oxide will be formed plus sulfur dioxide will be formed. When zinc oxide has been taken place, if you add any carbon to it, it will form carbon dioxide and zinc will be formed. These are the basic thing that can be taken. Manganese oxide and aluminium, it's a very important reaction actually. Each and every reaction which is given in the NCERT are very important. Thermit reaction. What is a thermit reaction? See, aluminium oxide, when it is added with iron, it will gives out iron oxide plus aluminium. It's a displacement reaction which will be producing lot of energy into it, so it is called as a thermit reaction. How copper can be separated? Through electrolysis. Okay, copper, and you can see the picture here. There is a impurity settled down, and that we call it as a anode mud. Cathode, which are negatively charged, and anode are positively charged. You have a confusion over there. No, you should not have that. Okay, corrosion, we know very well. No need to explain more on that, I hope. And why Qutub Minar, the pillar that is present, Ashoka pillar that is present in Delhi, why it is not rusted? That is what an amazing fact that is present. It's an alloy which is not rusted so easily. Okay, so these are the important questions just to go through. An important chapter, carbon and its compound. Carbon which will be have a valency 4, and that's the reason it has covalent compound. Okay, which will be sharing carbon compounds has been joined together, so it is called as covalent compound, where it is called covalent compound. Examples are many. Okay, example like methane gas CH4. See how to draw the structure of dot structure of methane. You have to draw this structure. Okay, you should be very careful on this, how to draw the structure of methane. And allotrope of carbon are diamond, graphite and Buckminster's fullerenes. C60. Okay, that is also sometimes they will ask these questions. What is a hydrocarbon? Carbon and hydrogen combines together, we call it as a hydrocarbon. It has saturated and unsaturated hydrocarbons. What are the saturated hydrocarbons? Saturated hydrocarbons which will be bonded with single. Okay, CC single bond are called as saturated, and CC double bond are called as unsaturated. Okay. CH4, okay, it's a methane which is a single bonded. Okay, ethane, if you go for two hydrocarbon, that is CC single bond, we call it as ethane, that's a saturated. If it is C2H4 as it's given here, this we call it as a double bonded, we call it as unsaturated hydrocarbons. Okay. So methane gases, methane, ethane, propane, butane, pentane, hexane, these are the number of carbon that is present in it. The structure is very important. Just go through once. It has two, this same molecular formula, for example, C4H10 is a common. Okay, how the arrangements can be written? Okay, that is called as isomers. Same molecular formula but different in structural is called as isomers. The structure of cyclohexane C6H12, the bond at the center is not there. That you have to be very careful. It's like a benzene but no bond or circle inside. That is called as cyclohexane. You have to be very keen. C6, 6 corners, and each carbon has 2 hydrogen in it. Okay, and benzene, structure of benzene C6H6, there C6H12, each carbon has 2 hydrogen. Here each carbon has 1 hydrogen each. Okay, homologous series. Before that, we have a the functional groups like halo groups, that is chlorine, bromine, iodine. Those things are called as halo groups. Alcohols, aldehydes, ketone, carboxylic acids, these are oxygenated functional group. Example, alcohol is OH, aldehydes are CHO group, ketone CO group, and carboxylic acid COH double bond O. You have to be very careful. All these things, aldehydes, ketones, and carboxylic acids are double bonded or unsaturated hydrocarbons. Alcohol is a saturated carbon. Okay, what are homologous series? Which will be obeying the formula and its functional group. Same functional group is called as homologous series. A very important question that is asked in the examination. Be careful on this. Some of the we have seen a lot in this. Yeah. Nomenclature. How to name a compound. It's very important. The tabular column which is given there, see alcohol where it has been placed, that is what very important. If it is placed at the right end of the corner, that is called simply we can write it as, see for example, propane, three carbons which has been joined together, at last it has been added with alcohol, that is OH group, that we call it as propanol. While saying it should be very clear, where writing also it should be at which place it has been occupied. At the last, if it is occupied, then it is called as 1-propanol. You have to go from right hand side. If you go from left hand side, then it is called as you have to go which is easy. First you have to look into the chain of hydrocarbons, then you have to find it out. If you check this, this is what the thing is. We have seen a lot in this. And okay, oxidation. See, methane gas or ethane, that is ethanol, when it is in presence of potassium permanganate or potassium dichromate, it will give ethanoic acid, CH3COOH. How many carbons are there in the right hand side? 2 carbons. So meth and eth, it's ethanoic acid. So most of you are writing as methanoic acid. That is not methane, as methyl group is added with oic acid, that is carboxylic acid group, even though it should be said. It's a very important reaction. CCH3CH2OH, that or C2H5OH in the presence of potassium permanganate, and when it is heated it will gives out ethanoic acid. How ethanoic acid has been prepared? It's a very simple reaction. And addition reaction. See, what is an addition reaction? When unsaturated hydrocarbon, when it is reacted in the presence of nickel or palladium as a catalyst, it will be forming a saturated hydrocarbon, same number of R. Each R is called as methyl group. Okay, 4 methyl group are present and left hand side in the reactant, and the same thing will be there in the right hand side even, but the double bond has broken into single bond and holds hydrogen each. And what is substitution reaction? Methane, when it is added with chloride gas, it gives out methyl chloride plus hydrochloric acid. It's a substitution reaction. It's a very important reaction too. Okay. And sodium, what will happen when a metal like sodium or potassium is added with ethanol, C2H5OH? Okay, it will form sodium ethanoate plus a hydrogen gas. And ethanol, when it is heated in presence of concentrated hydrochloric acid, it will be forming unsaturated hydrocarbon, that is called as ethene plus water. Very important question, which very important reaction too. Properties of ethanoic acid. What is the properties of ethanoic acid? It freezes soon, so it is called as glacial acetic acid too. Okay, esterification. What is meant by esterification? When ethanol is added with ethanoic acid in presence of hydrochloric acid or sulfuric acid, it will gives out ester. Okay, CH3C double bond O CH3CH2. Okay, that we call it as ester. The process is called as esterification. And saponification reaction, CH3COO C2H5 or ester, which has been taken into it, and when sodium hydroxide is added to it, it will form ethanol plus sodium ethoxide, where CH3COONA is called as sodium ethoxide. Okay, sodium ethoxide will be a product. Very simple how ethanol has been produced. Ethanoic acid, when it is added with ethanol in presence of acid, it gives out ester. From ester, if you heat with the sodium hydroxide, it will gives out ethanoic acid, sodium ethoxide and ethanol. So ethanol has been found. Okay, so when ethanol is found, ethanol in addition of potassium permanganate KMNO4 is added, it will gives out ethanoic acid. Very simple thing. It is a cyclic process. Okay. What will happen when ethanoic acid is added with sodium carbonate? It will gives out the same thing. Okay, CH3COONA, that is sodium ethanoate plus water. What will happen with ethanoic acid with sodium bicarbonate is added? The same thing, CH3COONA plus H2O plus CO2. Bicarbonate will be producing water molecule and carbon dioxide, that you have to be very careful. Soaps and detergent, very important thing. You know, detergents which will be producing have a measles in it. What are the measles? Measles which will be have a hydrophilic and hydrophobic. Phobic means fear of water, so it will be attached with oil to make a circle. What is philic? Love of water. Hydro means water, so which will be love with water, so it will go along with water. Which is hydrophobic, which will be attaching with oil, so it will make it as a two sides, it will make it as a spear and it will remove. That's why while washing it will make it as a spear and it will rotate it, and the oil stains will be removed easily. Missiles, like you can see the picture over here, the blue thing which is called as hydrophilic or love to the water, where the down one it's called as a hydrophobic, which is fear of water, which will love to the oil, which will be stick together, both will be forming as a spear and it will be removed. What are the salts that is present in the water? The soaps and other things, that is inorganic salts or not dissolving salts like magnesium, calcium salts will be used present into it. Okay, so those are the important things you can study. All the best.